Okay, good morning. My dear students, first of all, I would like to welcome you all in our virtual class. This will be broadcasted from Rhombus audio video chamber, and as well as it is going to be broadcasted from OSN channel as well. So today we are here for simplification chapter. Yesterday we have discussed some questions, and again today I am going to make you clear about some of the important questions that will be very useful, and as well as it is very important in the find up SE examination view. So today we will solve two more questions that can be very much important for you for the examination. So let us discuss today some of the questions that can be important for you. Today the first question here we have got x plus y upon x square plus xy plus y square plus x minus y over x square minus xy plus y square plus 2y cube over x to the power 4 plus x square y square plus y to the power 4. Okay, before starting the simplification, I would like to draw your attention in another chapter, because this is very much related to factorization as well. So let's see here, please. You have to look at final fraction, and you can see the denominator here, x to the power 4 plus x square y square plus y to the power 4. You need to learn how to factorize this one. So it is very much related to factorization as well. So I am going to teach you how to factorize this algebraic expression. That is very important. You can see it is a trinomial. It has got three algebraic terms. And so when we absorb this algebraic expression, you will find the first and the last, these two terms are square. I mean to say x to the power 4 and y to the power 4, these two terms are squares. So when we factorize, if we have got two terms are square, how to proceed or how to factorize the algebraic expression, I am going to teach you here. So let's write them together first. In this trinomial, let's write them together. And the middle terms you write at the back side. Yes. So you know very well this is square of x square. Could you tell me, is it square or not? Yes, it is also square. So we write here y square whole square plus x square y square. We need to write two squares together. And in these two terms, then you know we can compare this one with this form, a square plus b square. Yes, we know the formula for a square plus b square. The formula for a square plus b square is a plus b whole square minus twice ab, or a minus b whole square plus twice ab. Yes, we may have to use either of them in this case. When we will have two squares at a time, to factorize the algebraic expression of three terms, we need to write two squares together first, and then after, according to your need, we will have to use either of them. So this time I am going to use the first formula. X square is compared as a and y square is compared as b. So when we apply the formula a square plus b square for this, we need to write in this way. This is a plus b, y square is supposed as b, a plus b whole square. According to the formula we have got minus 2a. This is x square, this is y square. So x square is supposed to be a, y square is supposed to be b. So this is 2ab. And again we have x square y square. Well, then after, you can see these two terms are like terms. These two terms are like terms. So according to the sign, we need to subtract or add, but we have got different sign here in this case. So it tells you that we need to subtract them. So the first terms we write as it is, the first term we write as it is. Then when we subtract them, 2 minus 1 is definitely 1, you know. So x square y square you write together. So 1, we no need to write 1 here, but which one of them is bigger? We know this is bigger, so we have to write its sign. Yes. Now this is important step we have got here. Again, this is square and the next one is also square. Between them we have got minus sign. It means what here? These two terms are in the structure a square minus b square. I mean to say this is whole supposed as a and the next one is supposed as b. The difference of two squares means it is in the form of a square minus b square. In case of factorization, This is, we know we will have to use this formula, a plus b into a minus b. We have got two factors. So here, when we proceed the following steps, we will have to use this formula for the factorization. So when we apply the above formula, x square plus y square itself is supposed as a plus, then this is square of xy. So we can say this is a plus b, again x square plus y square is supposed as a, then according to formula minus we have, again xy is b here. Okay, I want to conclude in this way that when we factorize x to the power 4 plus x square y square plus y to the power 4, we get these two factors. And again, the reverse process, if we multiply these two factors, we will get this one. I mean to say, this is the product of these two factors. What I'm going to make you clear, I mean to say, this process is related to this simplification, and we can link this process here. So once again, I want to join you this question, I mean to say this factorization with this question again. Okay, my dear students, I'm going to relate the factorization and simplification. The factorization itself is very important for simplification. So I'm going to relate the factorization with simplification. So let's examine this question here. We have got three fractions: first fraction, second fraction, and third fraction. And when we simplify, we will have to begin from first two terms. Let's see here. We have got some kinds of similarities: x square, xy, xy, y square, y square. We have got some identical expression here. But we start simplification from the first two only. The last one remain as it is. So you have to wait for the last term. So you start simplification from simplification of first two terms. Yes, we can't factorize this denominator. If it is possible to factorize, first work is to factorize the denominator, but we can't factorize these two. So directly we take LCM of denominator and denominator. What will be the LCM of denominator? We don't have any kinds of common factors, so we write them together: x square plus xy plus y square, and again x square minus xy plus y square. This will be the LCM. Well, the LCM is divided by denominator of first fraction. This is LCM, this is denominator. When the LCM is divided by denominator, this and this will be cancelled. Then this will remain. It multiplies to numerator. Numerator here we have got x plus y is numerator. It is multiplied by x square minus xy plus y square we will get. Now the second fraction is remain. So what is the sign we have got here? Plus, so we write plus sign. If there is minus, we need to write minus. Again the same process we have to proceed here. For what? So this is LCM. The LCM is divided by denominator of second fraction. This and this cancelled. This will remain. It multiplies to x minus y into x square plus xy plus y square. Plus the last one, we don't change anything else. We need to write same as it is. We are just writing do. Do means just I'm here. You need to write in the examination, but just I'm writing as it is. It means, okay. Well, again some fundamentals formula we will have to learn. I have made you clear about two formula. This is one formula we will have to use. This is second formula we have used, and again some more formula we will have to remember. So I would like to remind you another formula. See here. Could you tell me what is the formula plus a cube plus b cube? What is the formula for a cube plus b cube? We do know very well that a plus b into a square minus ab plus b square. This is the formula for a cube plus b cube. That means when we multiply these two, we will get this one. And so when we apply formula for a cube plus b cube, we will use this formula. This is the structure you have to remember. And again, if these two are multiplied, this is the product of these two factors. You have to remember in this way also. Another thing, a cube minus b cube. That means the formula you will have to remember. Once again, I would like to remind you the formula: a minus b, a square plus ab plus b square. That means the product of these two factors will be a cube minus b cube. Here, once again, I suggest you to remember 1, 2, 3, 4. We have got 4 formula we are going to use here. So you must remember this formula. This is very important formula for your algebra. So once again, I would like to remind you this formula that I have quoted here. Well, let's compare these two factors with this one. With the first one, with the first one. Yes, this is suppose as a plus b, a square minus ab plus b square. That means x and y are present here for a and b. So we are very much clear according to this formula. When these two are multiplied, of course we will get x cube plus y cube. So similarly plus we have got, and then when these two are multiplied, this is compared with this structure. It means when we multiply these two, we will get the product a cube minus b cube. So x cube minus y cube we will write here downwards. Yes, now no need to write this bracket here. Okay, let's see at denominator. When we see at denominator, I have already made you clear before starting the problem. I have already made you clear that when these two are multiplied, the product we will get what? X to the power 4 plus x square y square plus y to the power 4. This is the chapters related to factorization that we have already done. This is the example I have just made for you to make you clear only. So when these two factors are multiplied, we will get this one. When this is factorized, we will get these two. So you should be clear about it. So I have given this example before starting this process. So the product of these two you will get here x to the power 4 x square y square plus y to the power 4. Do you have any question now? Why I have done this factorization before starting the problem? Just I want to remind you the process what we have done in factorization process. Well, plus do means that this one 2y cube over x to the power 4 plus x square y square plus y to the power 4. This is very important step. Yes, finally, well, now you will see plus y cube minus y cube. They are subtracted, then x cube and x cube. Both of them have got the same sign, so they are added. 2x cube upon x to the power 4 plus x square y square plus y to the power 4 plus 2y cube over x to the power 4 plus x square y square plus y to the power 4. Yes, this is remain. Now we have got just two fractions. Let's see the denominator. We have got same denominator, so the LCM of these two will be x to the power 4 plus x square y square plus y to the power 4. This is denominator. Then when this LCM is divided by the denominator, you will get 1 multiplies to 2x cube. You have got the same. Again, this LCM is divided by this denominator, you will get 1 multiplies to 2y cube, so you have got 2y cube. Yes, let's have two common. We can't add them, but we can take common. You will get x cube plus y cube. X to the power 4 plus x square y square plus y to the power 4. Okay, we are here now. Again, let's see there. 2 we have got here. And x cube plus y cube, this is in the form of a cube plus b cube. Let's factorize it because we need to factorize the numerator, we need to factorize the denominator. If there are some common factors, we can cancel numerator and denominator. So let's apply formula for x cube plus y cube. We will get x a plus b a square minus ab plus b square. We remember this formula. Again, let's see denominator. Once again, I would like to remind the first step, how to factorize and what are the factors we get when it is factorized. I have already given you example, because when they two are multiplied, we have got this one. That means the factors of this algebraic expression are these two. So the same thing we have to write here, x square plus xy plus y square into x square minus xy plus y square. You can see there, we have got 1, 2, 3 factors. We have got 2 factors. So in the numerator and denominator, if there are some common factors, we can cancel them. This and this will be cancelled. And finally, we have got 2 times x plus y upon x square plus xy plus y square. Yes, this is, you have got the answer. So this is the questions of 4 marks you may get in the examination. So it is very important. Lesser more similar type of question you can search in your book. You will find enough question. I suggest, my dear students, please you can have enough practice at your home. Please lesser more similar type of question. maybe set in the examination. So you just pay sincere attention on this question. Thank you very much. Okay, again this is the third question that will be important for the examination. This is the third question. We have already solved two more questions already. Now this is the third questions that will be frequently asked in the examination. So technically we will have to solve this one. So I would like to remind you this question also once again. Let's see the questions. This is related to law of indices also, and as well as we will have to simplify as well. But this is the question that is related to the simplification chapter. So you examine these questions. Here you can see denominator in the first fraction, in the second fraction, in the third fraction. When we examine in the first fraction, the denominator first fraction, let's see here, x to the power m minus l, x to the power n minus l. So to simplify these kinds of questions, then since we have got here minus l, the numerator and denominator both should be multiplied by x to the power l. Here in the second fraction you have got n minus m. Let's see here this one please. Let's see minus m here, minus m here. So the numerator and denominator both should be multiplied by x to the power m. This should be multiplied by x to the power l. And in the last term, in the last fraction, you can see minus l, minus n, minus n. So the numerator and denominator both should be multiplied by x to the power n. So why we are going to multiply numerator and denominator by x to the power n? Why we are going to multiply x to the power m? We are going to multiply numerator and denominator by x to the power m. I am going to make you clear. Here, x to the power m minus l, if we break this one, what do we get here? X to the power m into x to the power minus l we will get. So, when we multiply them, we will get this product. So, now please, if x to the power m and x to the power minus l, if this is multiplied by x to the power l, what will you get? See here, when they two are multiplied, you will get x to the power m into x to the power l into x to the power minus l. X to the power m, they two have same base. So let's write common base when we multiply them. L plus minus l. Plus minus minus, that means x minus l we will get. X to the power m into x to the power l minus l means x to the power 0. X to the power 0 means 1. Finally we have got x to the power m. So we will get such kinds of easy term. Because of what? We are going to multiply numerator and denominator by x to the power l. The same process we have to proceed for this and this. So we are going to simplify from the complexity, because of what? The numerator and denominator both are multiplied by x to the power l. Numerator and denominator both are multiplied by x to the power l. So x to the power l, once x to the power l downwards, x to the power l multiplies to 1 plus x to the power m minus l plus x to the power n minus l. In the second term, the numerator and denominator both are multiplied by x to the power m. Why we have chosen x to the power m, we have already said. So x to the power m multiplies to 1 plus x to the power n minus m plus x to the power l minus m plus, please let's see here, minus n. So the numerator and denominator both are multiplied by x to the power n upon x to the power n multiplied to denominator also 1 plus x to the power l minus n plus x to the power m minus n. Okay, now how to multiply? See here, the first one, if I can make you clear, all the remaining will be very easier for you. So I'm going to focus the first fraction, x to the power l you write as it is. In case of denominator, x to the power l ones are x to the power l plus, when this and this multiplied, when we will multiply these two terms, what you will get the product? Let's find here. I am going to show you here in this corner. x to the power L multiplied to this one. That means into x to the power m minus L. And we have got same base, so let's write common base. The numerator, according to law of indices, the indices are added, L plus m minus L. Then plus L and minus L, we will cancel them. Then x to the power L, m will remain there. So directly we can write here x to the power m. Plus, when this and this multiplied, you will get x to the power n. Lesser or more similar process. Finally, x to the power m in the numerator you write as a denominator. X to the power m 1 is x to the power m plus. Please, what we will get now? See here. What we will get here when they two are multiplied? Then we know x to the power n you will get. X to the power L only you will get. It is very easy. The first only you will get. Similarly, x to the power n upon downwards, x to the power n 1 is x to the power n plus when j2 are multiplied, minus and minus plus you will cancel. Then you will get x to the power L plus x to the power m. Okay, let's see the three fraction. And you just look at the denominator. Denominator. Yes, the order are different, but all of them have got same sign, same term. Because of what? All they are same. So to simplify them, you can write, when you take the LCM of all these three, you will get this one, x to the power L plus x to the power m plus x to the power n. Only you will get. Then the LCM is divided by this one, you will get 1. 1 into this is x to the power L plus this is divided by this one. 1 multiplied to x to the power m plus x to the power n. Finally, we have got a numerator and denominator same. Let's cancel them. We have got the answer 1. Thank you.